Hi again, welcome to section 8 on multiplying decimals. Unlike addition and subtraction, you do not need to line up your decimal points. To make it easier, rewrite the problem so that the number with the more digits is on top and then multiply traditionally. Not sure if you ever learned the lattice method in elementary school, but we do not want you utilizing that here. Once you get the answer, count how many digits are behind the decimal point in the original problem and make sure that the same number of digits are behind the decimal point in your solution. Okay, so let's get started with this first example. So we have 3 and 2400ths being multiplied by 7 and 1/10. It's a little, sorry guys, there it goes. Okay, so I'm going to write that problem right here. And you'll notice that this one has 3 digits in it and 7.1 only has 2 digits. So I'm going to put that one on the bottom. All right, I'm going to do some color coding here so that you guys can, if you're not familiar with the traditional method of multiplication, you can kind of follow along here. I'm going to highlight this right here in my tenths place in orange, and I'm going to highlight my ones place in green here. And the reason I'm going to do that is because when I go through and do the multiplication, I want you to see why I'm putting certain numbers in a certain place. So I'm going to multiply everything up on top here by 1, and I'm going to use orange as I highlighted that in orange. So 1 times 4 is 4, 1 times 2 is 2, and 1 times 3 is 3. Notice I'm ignoring those decimal points right now. We're just going to multiply everything traditionally for a moment. All right, notice in the next place value, we're skipping over to the next place value. So I want to put a little 0 placeholder right there and skip right over to the second place value. 7 times 4 is 28. 7 times 2 is 14, plus 2 more makes 16. 7 times 3 is 21, plus 1 more is 22. Then what you're responsible for doing is just adding what you have here. So I'm just going to add straight down 4, 10, 10 again, 3, and 2. And what was said above about counting how many numbers are behind the decimal point, notice in the problem we have 2 numbers here, and a third number here behind a decimal point. So that means in our answer we need 1, 2, 3 numbers behind the decimal point. And it's really important here for you guys to use a little bit of estimation and common sense. Look at the original problem. 3.24 is just a little bit more than 3, and 7.1 is just a little bit more than 7. What's 3 times 7? 21. Look at our overall answer. It's just a little bit more than 23. So our answer does make sense. Whereas if we had our decimal point in any other position, it would not have made sense. All right, go ahead and look at the next example. The one with more digits is this first one. 23 and 4200ths being multiplied by 40 and 2/10. All right, I'm going to do some highlighting again. I'll do orange, green, and yellow. We're not sure how well yellow is going to show up here. All right, so I'm going to multiply everything in the top by the number I highlighted in orange, and I'm going to write in orange. 2 times 2 is 4. 2 times 4 is 8. 6 and 4. Next row. Again, I'm skipping place value, so I put a 0 placeholder right there. Notice that my next number that I'm multiplying everything by is a 0, but I'm going to include this row. 0 times 2, 0 times 4, 0 times 3, 0 times 2. This is where mistakes tend to happen, so it's important to remember that step. In my last row, I'm going to do in yellow. We'll see how well this shows up. Notice it's the third digit over, so I need my third place is where I'm going to start here. 4 times 2 is 8. 4 times 4 is 16. 4 times 3 is 12, plus 1 more is 13. 4 times 2 is 8, plus 1 more is 9. All right, I'm going to add them all up. I won't write with yellow. 4, 8, 14. That makes 11. 3 plus 1 is 4. 9. Count how many digits are behind a decimal point. 1, 2, and 3. So I need 1, 2, three numbers behind a decimal point in my answer. So 941 and 484 thousandths. Alright, check out the next one. The number that has more digits in it happens to be the second one, so I'm going to put that one on top. 4.005 on top and 1.25 on the bottom. I'm going to do some highlighting again. Not necessary that you do that, just some of you are not familiar with the traditional method or not comfortable with it. So we want to make sure that you kind of see some relationships here. Alright, so the first thing I'm going to do is multiply this 5 by everything in the top row. So this makes 25. 5 times 0 is 0 plus 2 more. 5 times 0, 5 times 4. Next row, and then multiply everything by the green 2. Putting a place value holder right there. 2 times 5 is 10. 2 times 0 is 0 plus 1 more. 2 times 0 is 0. 2 times 4 is 8. Alright, next row, I'm in the third place, so I need place value holders. 1 times 5. 1 times 0. Another 1 times 0. And 1 times 4. Alright, add them all up. 5, 2, 6, 0, 10, 4 plus 1 is 5. How many digits behind a decimal? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And look at the answer. It's really just a little bit above 5. And our original problem is a little bit more than 1 times a little bit more than 4. So that answer does make sense. Alright, good luck with section 8 on your summer packet.